Friends, welcome to my channel. Dhanesh here.
Let's first discuss on quantum information. Quantum information is the information of the state of a quantum system. It is the basic entity of study in quantum information theory and can be manipulated using quantum information processing techniques. In quantum computing, a qubit or quantum bit is the basic unit of quantum information. The quantum version of the classical binary bit physically realized with a two-state device. Important point is quantum information is conserved. That means quantum information cannot be created or destroyed. Quantum information can neither be created nor be destroyed. In the quantum world, however, the conservation of quantum information means that information cannot be created nor destroyed. This concept stems from two fundamental theorems of quantum mechanics, the no-cloning theorem and the no-deleting theorem. Let's discuss quantum no-cloning theorem. Quantum no-cloning theorem is a result of quantum mechanics which forbids the creation of identical copies of an arbitrary unknown quantum state. It was stated by Wouters, Szurek and Dijks in 1982 and has profound implications in quantum computing and related fields. Next, let's discuss on quantum no-deleting theorem. The no-deleting theorem of quantum information theory is a no-go theorem which states that, in general, given two copies of some arbitrary quantum state, it is impossible to delete one of the copies. It is a time-reversed dual to the no-cloning theorem, which states that arbitrary states cannot be copied.
The basis of quantum computing is the qubit. In quantum computing, a qubit or quantum bit, sometimes qubit, is the basic unit of quantum information. Unlike a normal computer bit, which can be 0 or 1, a qubit can be either of those, or a superposition of both 0 and 1. We will discuss about some practical examples of qubit. One is spin of electron, which is angular momentum of an electron. The second one is polarization of photon. The spin of an electron, as I told, it's a type of angular momentum in which the two levels can be taken as spin up and spin down. The polarization of a single photon in which the two states can be taken to be the vertical polarization and the vertical polarization and the horizontal polarization. In a classical system, a bit would have to be in one state or the other. However, quantum mechanics allows the qubit to be in a coherent superposition of both states simultaneously, a property which is fundamental to quantum mechanics and quantum computing. What is superposition? See, superposition and entanglement are two features of quantum physics on which these supercomputers are based. This empowers quantum computers to handle operations at speed exponentially higher than conventional computers and at much lesser energy consumption. Superposition refers to the quantum phenomenon where a quantum system can exist in multiple places or multiple states at the exact same time. In other words, something can be here, there, up and down at the same time. Comparison between bits and qubits. For a system of n components, a complete description of the state in classical physics requires only n bits, whereas in quantum physics it requires 2 raised to n complex numbers. A quantum computer consisting of n qubits can exist in a superposition of 2 raised to n states. If you add more bits to a regular computer, it can still only deal with one state at a time. But as you add qubits, the power of your quantum computer grows exponentially. We can say that if you have n qubits, you can simultaneously represent 2 raised to n states. Thanks for watching. Please like, share and subscribe. Thanks a lot.